Right, so today we're taking a look at Section A here in Unit 1. We're looking at slope of a line. So what we want to be able to do by the end of this lesson is to find the slope of a line from a graph, which is something that you did last year in grade 9. We also want to be able to find the slope of a line from just given the coordinates of 2 points that are on the line. So this second method here is going to involve a lot more algebra, which, consistent with our course, we're looking in grade 10 to do things a little bit more algebraically than we did them in grade 9. And finally, we'll take a look at a question at the end where we find the coordinates of points, again, using algebra, using the slope of the line and information about the other points. And as we're working our way through this, what we're going to do is we're going to develop an equation or a formula for the slope of a line. And that's the formula that is going to appear on your formula sheet that you're going to be using as you do most of the questions in the practice work for Section A here. Okay, so let's just start off with a little review of what the heck slope is. Okay, you encountered this word last year in grade 9. Slope tells us the steepness and the direction of a line. Okay, the larger the number of the slope, the steeper the line. And you probably use this formula for slope of a line, rise over run. So we've got two graphs of two lines here. We've got line AB and we've got line GH. Just by looking at the graphs, we can see that one of these lines is steeper than the other. Okay, line GH over here is the steeper one, and this one here is less steep. The other difference we can see in these two lines is line AB is going sort of up as we go from left to right. GH is going down as we go from left to right. And we're going to talk about how these two sort of descriptions of the lines are reflected in the slope that we calculate when we do our calculation here. So the way we did slope last year in grade 9 was, again, we used this formula, rise over run. So we drew these little triangles, right angle triangles, and this was our rise here. The vertical change in our line as we go from one point to the next, and our run was down here at the bottom. So for this line AB, our rise is, we can just count the boxes, 1, 2, 3, 4, 5. Our run is 1, 2, 3, 4, 5, 6. So our slope is rise over run, 5 over 6. Okay. Notice that this is a positive value because our line is going up as we go from left to right. For our second line over here, GH, our rise would be this vertical distance here. Our run, this horizontal distance across the bottom. Our run is 3. Our rise is 1, 2, 3, 4, 5, 6 boxes. But because this line is going down as we go from left to right, it's not rising, it's falling. So our slope is, our rise, sorry, is -6. Okay, negative because it's going down. So it's actually falling. So our slope, rise over run, is -6 over 3. And of course, we wouldn't leave it as -6 over 3 because that -6 divides evenly by the 3, so we would divide that to get -2. So our slope here is negative because this line is going down as we go from left to right. And if we compare the numbers, 5 over 6, 5, 6, and 2, we can see that this is 2 is a larger number, okay, making this line steeper. So you covered all that kind of stuff in grade 9 last year, okay? Rise over run, finding the slope by counting the boxes on a graph, okay? Let's see if we can make this process a little bit more algebraic, okay? We're going to start from this formula, rise over run here, okay? And we're going to look at this third graph here. We've got a line CD. Okay? Another way of explaining what the rise is that it's the change in the y coordinate. So as we're looking at, how this rise rate in here, this distance that it's rising is the change in y. Okay? And a mathematical symbol for change in something is a little triangle pronounced delta. So we can say that this is delta y. Okay? Similarly, for our run, it's the change in our x values, or change horizontally. So this distance along here is the change in x as we go from C to D, which we can call delta x. So another sort of way of calculating our slope is change in y over change in x, or delta y over delta x. Now, how do we figure out what the change in y is and what the change in x is? Well, up at the top here, we've got, we can kind of do it generally by saying, okay, what is the end value and what is the start value? And then subtract them. So for our y's here, as we're going from C to D, we end up with a y value of 3. Okay, that's our end value. Okay, we start on a y value of 1 down here. So 3 minus 1, our change is 2. Okay, again, we've gone up 2 spaces here. For our x, we end up on an x value of 9. We started at an x value of 3 at point C. So 9 minus 3 is 6. So our slope, change in y over change in x, is 2 over 6. Okay. And we're not going to leave it as 2 over 6. I'll just make this a little bit longer here. Slide this down so it has a little bit more room. We're going to put this in lowest terms. Both the 2 and the 6 can be divided by 2. So we can write this as 1/3. This is divide by 2 here, divide by 2 down there. Okay. So we can get our slope by looking at the changes in the x values or the changes in the y values. Okay. All right. Well, let's make this even a little bit more mathematical here. Okay. Again, slope still rise over run. We're still looking at the slope of this new line here, EF. What happens if we just consider these points E and F? Okay, we'll call one of them point 1, and we'll call one of them point 2. Okay. For point 1 and point 2, well, let's figure out what the coordinates are of point 1. Point 1 is our point E. It is at coordinates 2, 7. Point 2 is our point F. It is at coordinates 7, 3. Where, we've got an x and a y for each of these. All right. So let's say we want to find the change in y, because we're going to use, this is change in y over change in x. Okay. For our change in y, we said it was just sort of the end point minus the start point. So we can take our second y value, y2, And our first y value, y1, and again, we can do end minus start, just like we did before. Our end, we should say end minus start, or our y2 minus our y1 is going to give us 3 minus 7, which is negative 4. We can do the same thing to get the change in x, right? We've got an x2 here, an x1 here. So again, if we do end minus start, our ending value is 7. Oh, sorry, let's say x2 minus x1 again. Our ending value is 7. Our starting value is 2. 7 minus 2 is 5. So our slope, change in y over change in x, is going to be negative 4 over 5. Okay. So we can get our slope by looking at the change in y and the change in x, and we can get the change in the y and the change in x. We can get the change in y by subtracting the two y coordinates, and we can get the change in x by subtracting the two x coordinates. Putting this all together brings us to the formula that we want to actually use here for calculating the slope of a line. Okay? Our slope is y2 minus y1, x2 minus x1. Okay? Or, I mean, again, this is just change in y over change in x. So we've got a graph here. We want to find the slope of the line. Let's figure out first what are our 2 points that are on this line. Our points. Well, let's see. We're looking at this graph here. We've got to choose points that it's fairly easy to get coordinates of. Okay, so we'll choose a point right here. That's the point 0, 4. We'll choose a point down here. This is the point 6, 0. We want to calculate our slope. y2 minus y1, x2 minus x1 is the formula that we are going to use. So with our 2 points, let's just label one x1 and y1, and label the other one x2 and y2. So let's say this is our first point here. We'll call this x1. We'll call this y1. We'll call this x2. We'll call this y2. And we will sub those values into our formula. Our y2 value is 0. Our y1 value is 4. So 0 minus 4 up in our numerator. Our x2 value is 6. Our x1 value is 0. So that gives us 6 minus 0 in our denominator. So our slope is going to be, let's see, 0 minus 4 is negative 4. 6 minus 0 is 6. We get a slope of negative 4 over 6. Or, dividing each of those by 2, negative 2/3. Okay. And so this matches what we can see in the graph here. If we go back to the graph and look at it, we could see that, yeah, our rise here is negative 4. Our run down at the bottom was 6. So again, we see our slope is going down as we go from left to right. So we end up with a negative slope, negative 4 over 6. Okay. So from here on, basically, it's going to be this formula here that we're using to find the slope of a line. Okay. So let's try using this one more time here. Find the slope of a line between the points -1, -3, and 4, 7. Okay, let's start with our formula here. Slope is y2 minus y1, x2 minus x1. That's going to be our starting point no matter what we do. Okay. Let's label our points x1, y1, x2, y2. So this will be x1, this will be y1, this will be x2, this will be y2. And let's sub those numbers in. Our y2 value is 7. Our y1 value is -3. Our x2 value is 4. Our x1 value is -1. So 7 minus -3 in the numerator, 4 minus -1. So it helps put these brackets in here if your x or your y value are negative, because it helps you to get the signs right, just like we did when we were working with integers. So up in the numerator, 7 minus -3, those two negative signs together give us a positive sign. Same thing down in the denominator, we're subtracting a negative, it's like adding a positive. So our slope is going to be 10 over 5. 7 plus 3 is 10, 4 plus 1 is 5. 10 divided by 5 gives us 2. So our slope is 2. Okay. All right. So we will, I think we'll skip over this example here, and we'll jump right to the last question here. Okay. The line segment joining the points x16 and -5, 4 has a slope of -4 over 3. Find the value of x. So this isn't the same as the last questions we did, because they're not giving us all of the x values. They're giving us all the y values, 16 and 4, but we have this x value that's missing here. But we still want to use that formula, slope y2 minus y1, x2 minus x1. And we're going to start off the same way. We're going to look at our 2 points, and we're going to label our coordinates as either x1 or y1, x2, and y2. So let's decide that this is x1, this is y1, this is x2, and this is y2. Okay. And we can sub these into our equation here. Our y2 value is 4. Our y1 value is 16. Our x2 is -5. And our x1 is just x. So just like when we're calculating the slope, we just subbed in our x and our y values for x1, x2, y1, and y2. Now, what can we sub in here on the left-hand side for the slope? Well, they give us the slope in the question. Our slope here is -4 over 3. So let's write that in on the left-hand side. Okay. Now, what we can do is we can kind of break this up, and we can think of this, well, just like when we were solving equations, when we were solving equations, one of the things we looked for was, were there like terms on the left side and the right side that we could simplify before we tried doing any solving? So when we look at this, are there any terms or any operations that we can do to simplify this before we go ahead and try to solve for x? There is. Up here in the numerator, we've got this 4 minus 16. So we can simplify 4 minus 16. 4 minus 16 is -12. And we're going to keep everything else exactly the same. Now, one way of solving it from here is I've got an expression here that says that these two fractions are equal. The fraction -4/3 is equal to the fraction -12/-5 minus x. Okay. I can take these two fractions and try to get them to match up a little bit more than what they are right now by writing one of them as an equivalent fraction. So on the right, I see a -12 in the numerator. On the left, what could I do to try to get a -12 up in the numerator? Well, I could multiply this by 3, because multiplying that by 3 is going to give me a -12. If I multiply by 3 up in the numerator, I also have to multiply by 3 down in the denominator. I get a 9. And I'm going to keep everything the same. So we've gotten this now so that the two numerators match up. If the numerators match up and are equal to each other, then that means the denominators must also be equal. Denominators are also equal. Okay. So if the denominators are equal, that means that 9 has to equal -5 minus x. Okay. It's like you can split this into two little equations. There's the equation between the two numerators, -12 equals -12, and the equation with the two denominators, 9 equals -5 minus x. But you can only do this if these two numerators match up with each other. Okay. Well, now we've got this little equation to solve. We know how to solve something like this. We can add 5 to both sides, which is -x, and then divide both sides by -1. X will equal -14. Okay. So the key to this kind of question is set up your formula for slope, sub in the information that you're given, simplify it a little bit, get your numerators or your denominators to match up, and then solve that final mini equation.